Hey everyone, Chang here and welcome to my channel. This is the Bare Minimum Algebra series. Now for today's video, it's actually extremely difficult because I was trying to figure out what is the medium, the perfect balance of how many different possible cases you would encounter, how many steps for each of those cases that you would need to take to solve those system of equation, and there was a lot. So there's two main ways of solving system of equation. There is the adding / subtracting the system of equation, otherwise known as the elimination method, and there is the substitution method. So today's video we're going to focus on the elimination method. Now for this elimination method there is three possible scenarios that you would normally encounter. Okay, the first one is the most ideal. It's the easiest one. Out of the two variables that you would encounter, the x and y usually, right, you would have the coefficient of one of the variables be directly opposite each other. What that means is that, for example, you have a 2x and the next equation in the system of equation is a minus 2x or a negative 2x, right? Or it could be on the y. You can have a 4y and the other coefficient in front of the variable is negative 4, right? So if you have case 1, that is the most ideal, that is the easiest one to solve. It consists of 3 steps. Now case 2, one of the coefficients is exactly the same, right? So if you have 4x, the other equation in that system of equation also is 4x. If you have 10y, the other equation in that system of equation also has 10y, or negative versions, right? Negative 9x, and then the other one's negative 9x as well. Basically, one of the variables have exactly the same coefficient. Now, this is also great. Not as good as case 1, but still very manageable. 3 steps. For case 3, which, sad to say, is the most common that you would encounter, is when none of the coefficients are the same, right? You have one that is 2x and the other one is 5x, or whatever, right? This case is slightly more challenging. Therefore, there is 5 steps that if you follow, you would guarantee to solve the system of equation. So the difficulty with this elimination method is not necessarily remembering the steps, because the steps are actually not all that bad. They're very closely related. The difficulty is to realize which of the case that each and every one of the scenario you will encounter falls under, and then taking the appropriate steps, right? You don't want a situation where it is actually case 1 and then you think it's case 3 and you start making your life a little more challenging. Yeah, you can. You'll probably still solve it correctly, but why make your life more difficult? Remember, this is bare minimum. So that's enough of me rambling as an introduction. Let's just go over each and every one of those cases. I will solve one example problem and show you how you can identify them, and then, we'll solve them. All right, so as mentioned, the first case is when the coefficients are exactly the same. Now, the 3 steps are the following. First and foremost, because the coefficients are exactly the same, what you're going to do is you're going to have one equation and another equation exactly on top of each other. Of course, there is a format. You want all your x and y to be directly aligned and the answer on the other side of the equal sign directly aligned. And what you're going to do is you're going to add directly down. And you're going to see in the example what I mean in a second if that is entirely confusing, which is reasonable. Right? So after you add directly down, you're going to get a resulting equation. It's just going to be an equation with a single variable. Now, in that situation, what you're going to do is you're going to solve for what that variable is. You're going to get either x equals blah, 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 or y equals blah, 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 right? And from then on, what you're going to do is you're going to pick one of the 2 equations that you had originally. You're going to plug in that variable you just solved, and you're going to find the other variable, right? After you solve for the other variable, you have your x and your y, and basically the combination of those 2 is your answer for your system of equation. So 3 steps. Add directly down. It'll give you an equation. Solve that equation. You get one of the variable. Get that variable, plug it into one of the 2 equations that you were originally given, solve for the other variable, then you have both variable, and that is your answer. So let's look at an example of case 1. Here's an example of case 1. Interestingly enough, it actually could be considered case 2 as well. I really wanted one that you can see that even if you somehow have misidentified case 1, case 2, case 3, even though I said it's the hardest part, when you misidentify it, as long as you follow each and every one of these steps, yes, you made your life a little more difficult, but it doesn't mean you will get it wrong unless you solve it completely incorrectly. So this is a case 1 where that's the easiest way to interpret it. However, if you interpret it as case 2, that's entirely fine. You can go through the steps of case 2 and you can still solve it. But what makes this case 1 is this right here. Notice that in front of the y, which is the coefficients in front of the y, one of them is a positive 2 and the other one is a negative 2. So this is what I mean when I say that the coefficient is directly opposite of each other. The same number, but one is positive and one is negative. This is ideal. And notice the other thing that I wanted to point out is that you have to make sure that the structure is completely aligned. All the x are aligned with the x, all the y's are aligned with the y's, and all the regular numbers are aligned with the regular numbers, right? And then you can add, or case 2, subtract straight down. So from then on, what's going to happen is fairly simple. As the first step, you're adding straight down. 3x plus 3x is 6x. This right here, negative 2x plus 2x, cancels each other out. That's what we want, right? That's why it's called elimination. This one is a 0. We're going to leave it blank because adding a 0, yeah, it's great. You can see it. I'll just put it in red, right? Just so you know what's going on. Add or subtract a 0. And this one, add straight down, is 18. So basically, your resulting equation is 6x equals 18. Now, from then on, you're going to solve. You divide by 6 on both sides. This 6 goes away. And then now you have x equals 3. That is one of your variables. So step 1, right? Add straight down. Step 2, solve the resulting equation. You get one of the variables. Step 3, pick any one of the two equation and you're going to plug in x and you're basically going to solve for y. So in this case, just because I don't like negatives all that much, I'm a lazy person, I would rather choose this one that's all positive. Looks nice. So it's going to be 3, and instead of x now, we're just going to substitute 3 in there, plus 2y equals 13. Okay, and then that's basically 9 plus 2y equals 13. You subtract 9 on both sides. This goes away. You have basically 2y equals 4. Divide by 2 on both sides. And you have y equals 2. And there's your second variable. Once you get these two variables, x equals 3 and y equals 2, that is the answer for this entire system of equation. All right, so let's talk about case 2. Case 2 is when the coefficients are exactly the same. Now, it's very similar to case 1. However, both of them are either positive or both of them are negative. So instead, the only difference between this and case 1, you have to subtract directly down. Case 1, since they're opposite, you can add directly down. Case 2, if they are exactly the same, you're going to have to subtract directly down. The same two following steps are solve the resulting equations, right? Same thing. And then you're going to get the variable. That variable gives you some blah, blah number, right? Then you're going to plug it in to one of the two original equations and you're going to solve for the other variable. Once you get those two variables, once again, you have the answer. So let's look at a case of that. All right, so here is an example of the second case. Now, of course, I got to add some fraction, you know, make it a little scary. But other than that, it's actually exactly the same, right? So notice that, all right, this is two different coefficients. Not really our purpose right now. We just make sure that we know there's an invisible one right there, just because it makes our life easier, right? If there's not a number in front of the variable and there's a variable there, just imagine an invisible one. Now, right here, we have two coefficients that are exactly the same. Since they are exactly the same, our first step is that we actually have to subtract this whole thing from the top. So This is the way it's going to work. When you subtract, make sure you basically distribute the minus sign on everything. You're just subtracting everything down, right? So, in this case, 1/4 x minus 1/4 x, that is your 0. Let's make sure it's a red so you can see that it doesn't really matter at that point, right? And then you're going to have your plus or minus. In this case, it's going to be plus, because 3y minus 1y, remember, even though there's a positive, you're a minus right here, so it's going to be minus 1y, that's going to be 2y. And then you're going to have a 6 minus 4, which is 2. Okay, very simple. This resulting equation, all you have to do is solve for y. You divide by 2 on both sides. And you have y equals 1. Excellent. That is one of our first variable. Okay, so you pick one of the original equation and then you solve for x. Well, in this case, they're both positive. I'll just pick the first one because the second one looks a little messier now. So it's going to be 1/4. And if we have our x, we still don't know what that is. We have our y though. It's going to be plus 3 times 1 equals 6. Okay, that means it's 1/4 x plus 3 equals 6. Subtract 3 on both sides. Then you have 1/4 x equals 3. Now, in order to get rid of the 1/4, since it's a fraction, you would multiply by 4 on both sides. So that means we have x equals 12. And that is our second variable, and there you go. With both variable, you have the answer in the second case. Hopefully you guys can see this because it sort of fills up the board, but here's case 3. Case 3 is when you have different coefficient. As mentioned, that's the most common one, so sucks. Anyways, when we encounter case 3, basically we can convert it back to either case 1 or case 2 by the first 2 steps. Then 3, 4, and 5 are basically either case 1 or case 2 and how you would normally solve the system of equation. So the first one is fairly simple. Because the coefficients are all very different, you can build up an experience and choose the easier one, but if not, just pick one of them. Pick one of the variable you want to focus on first. That's the key. Because the second one, what you're going to do is you're going to multiply the top and bottom by the other coefficient. So what that means is this. Let's just say, for example, I pick x as my focus variable. One of the x is a 2x, the other is a 7x. What I'm going to do is I'm going to multiply that entire equation with the 2x by 7, because the 7 is the other coefficient. So the equation with the 7x, with the 7 as a coefficient, I'm going to multiply by 2, the entire equation by 2, because 2 is the opposite or the other equation, right? It will make more sense in the example. But basically what you're doing is when you multiply the top equation by the coefficient of the bottom equation, and the bottom equation by the coefficient of the top equation, you've all of a sudden converted that system of equation into case 1 or case 2. Once you encounter case 1 or case 2, then you act accordingly. You're either going to add directly down or you're going to subtract directly down. Then you're going to solve the resulting equation like any other. And then once you solve the resulting equation, you have your variable. You're going to plug it back into one of the original equation before you did all the crazy conversion, right? And then you're going to solve for the other variable. Once again, once you get those 2 variables, you are done, right? You have found the answer to the system of equation. So 5 steps, but it's not as bad as it seems. Let's go over an example so you can see exactly how to go about it. All right, so here is a case 3. Once again, I wrote this problem just to make it as confusing as possible. No, not really. I wrote it and it might not turn out to be a very nice problem. But I wanted to point out something very quickly because I started to realize as I get more technical and explaining the fact that certain coefficients need to either be the opposite or exactly the same. I do want to emphasize, notice this problem. the coefficients are actually all very different. Yes, we have a -5 here and a -5 here, but what I really should have said is that the coefficient has to either be directly opposite or exactly the same with the same variable, right? Because remember, our goal is to eliminate, right? We want to add directly down or subtract directly down so that one of the variables just goes away. It becomes a 0. In this case, even though you have a -5 and a -5, if you add directly down or you subtract directly down, right, the variables don't go away. So that's something we need to be careful of, right? For case 1 and case 2 and case 3, right? When we're talking about whether the coefficient is the same, the opposite, or completely different, we're just talking about in comparison to the same variable. Okay, so in this case, this is a case 3. There is no same variable, same or directly opposite coefficient on the same variable. Wow, I'm getting tongue-tied today. All right, so what we're gonna do is our first step, we're gonna focus on one of the variables. I'm just gonna focus on x because x is right there and it's not in the middle of the problem, and I don't know, I definitely prefer x over y anyways. And what I'm gonna do is I'm gonna multiply top and bottom by the other coefficient. So since I'm focusing on x, I can ignore everything else right now. I'm just looking at the two numbers in front of the x. This one is a 2, this one is a 5. Ignore the minus sign, right? And then we're gonna multiply. Well, since this one is a 2, what I'm gonna do is I'm gonna multiply the bottom by 2. Since this is a 5, I'm gonna multiply the top by 5. And now I'll get a new system of equation. So basically what I'm going to get is going to be 10x, and then remember you're multiplying every one of them, so it's going to be minus 25y equals 10. Okay, and this one's going to be a minus 10x, that was a terrible minus sign, minus 10x plus 15y, is it 15y? No, 6y, what am I doing? 6y, come on you guys. Sorry, I'm tired right now. 6y equals 8. There we go. Now, this puts us in a situation that is basically case 1. Notice that now we have a case where the coefficients are direct opposites of each other. So we're going to add directly down. That is 0, which is what we want. And then this one add together is, yeah, this is not going to be a nice problem. Minus 19y equals 18. Divide by negative 19 on both sides. And so now you have your y equals negative 18 over 19. That's one of them. An ugly one of them, but one of them nonetheless. All right, so now what we have is y equals blah, blah, blah. We pick one of the original equation, not the ones that we changed. One of the original equation, and we're going to plug it in and we're going to solve for x. So I'm just going to pick let's pick the first one. You're going to have 2x minus 5 times negative 18 over 19 equals 2. Okay, well, that's going to give me 2x, that is what, minus 90. All right, cool. So minus minus plus, so it's going to be plus 90 over 19 equals 2. Okay, and then we're going to subtract 90 over 19 on both sides. That'll give me, what is that? That's 38, right? You know, fraction math. That's 38 over 19, converting. And when I subtract that, that is what, 52. Yes. So I would have 2x equals negative 52 over 19. And in order to solve, hopefully this is on camera. If not, then let me just rewrite it right here. 2x equals negative 52 over 19 and 19. And we're going to solve by dividing by 2 on both sides. Divide by 2. And we get x equals negative 26 over 19. And there you go. This is what happens when you don't plan a really lovely, beautiful math problem and it becomes ugly with lots of negative fraction number. Now, there we go. So y equals a negative 18 over 19, and the other one, x equals negative 26 over 19. Now, those are the answer for this particular problem. All right, so this is near the end of the video. Now, here's one thing I want to emphasize, and I emphasized it in the beginning of the video, so I'm going to emphasize it now because this is something that, being a very mean math instructor, I would definitely do to my students. So pay careful attention. Notice all of these equations, all of these examples, I've already aligned the x on top of each other, the y on top of each other, and the numbers on top of each other, right? There will be cases where they're not aligned. In that situation, you have to make sure you do all your fancy math magic trick, adding, subtracting, multiplying, dividing, manipulating it in such a way so that they are aligned, right? As an instructor, as a mean instructor, teaching this and then just giving students or having students understand a certain way of solving step by step, a trick way to throw them off is, you know, this one's x and I might make this one y. And all of a sudden they're adding it straight down or subtracting straight down, and it becomes a jumble mess. So you just have to be very careful and pay attention. Make sure that the variables are directly aligned. It doesn't have to be in this order of x on this side, y on this side, some number. It could be y, x, and then some number or whatsoever. As long as they are lined up directly, you're good to go. Okay, so there you have it. Let's summarize very quickly because there was a lot of different cases with different steps. First case, coefficients are directly opposite. One is positive, one is negative. That's your ideal case. All you have to do is add the two equations directly down, solve the resulting equation, get that variable, plug it back into the equation, and then you solve for the other variable. Case 2, very similar to case 1. The coefficients are exactly the same, so what you're going to have to do, instead of adding, you're going to subtract the equation straight down, right? Once you subtract it, once again, you get the resulting equation, solve that, get that variable, plug it back into the original equation, and solve for the other one. Now, the last one is fairly simple, just more steps. That's when none of the coefficients are exactly the same. So what you do is you first pick your focus. It could be x, it could be y. As you build more experience, you're going to see one is a lot easier to work with than the other. But in this case, just pick whatever you want. And then what you're going to do is you're going to multiply the top equation by the coefficient of the bottom and the bottom equation by the coefficient of the top, right? Based on the variable that you're focusing on. Then you have case 1 or case 2, solve it, solve the resulting equation, grab that variable, plug it back into the original, and then you get your answer. So there you go. This was a long video.